Hi everyone, today we are going to talk about the laboratory for LabView.
Next, my partner and I will make a brief explanation about the flow charts for the different three tasks. For the first exercise, this is the flow chart. Start, set up LCD pins and global variables, configure microcontroller ports, initially set external interrupt and LCD screens, main loop, wait for external interrupt activation. After upon interrupt occurrence, read the state of the sensors, determine which sensor tried the alarm, activate alarm if applicable, clear the external interrupt flag, then update the LCD display. If intrusion is detected, display intrusion detect, show which sensor tried the alarm, else display the current state of the sensors, continue monitoring, in addition return to the main loop to continue monitoring and finally end.
The second flowchart start initialize LabView interface, configure microcontroller ports, set up data acquisition on microcontroller. The main loop, the first read analog sensor values from microcontroller, transmit sensor data to LabView via serial communication, receive control signals from LabView, control processes on microcontroller based on received signals, update LabView interface, receive sensor data from microcontroller, display sensor readings on LabView interface, send control signals to microcontroller, update LabView interface based on received data, continue data acquisition and control, return to main loop to continue monitoring and control, and finish the code.
In the direct exercise, the flow chart is as follows. Start on microcontroller 1 and 2, then configure ADC to read potentiometer, configure UART for serial communication, initially LCD to display data, main loop, read value of local potentiometer, display value of local potentiometer on LCD, transmit value of local potentiometer via UART, in addition, wait to receive data via UART, display receive data on LCD, continue main loop, and finally end.
Point 1. LCD pin definition. The microcontroller pins are mapped to the control and data pins of LCD display using the S-bit keyword. The LCD pin addresses are defined as input or output using the S-bit keyword. Global variables. Three global variables are declared: sensor activated to indicate which sensor activated the alarm, windows to control whether a specific message has been displayed for the window state, and POW to control whether a specific message has been displayed for the door state. External interrupt routine. An interrupt routine is defined that is activated when there is a change in the RB0 pin. An OR gate was used to achieve the objective of point 1. Depending on the state of pins RB1, RB2, or RB3, the value of sensor triggered is set to indicate which sensor triggered the alarm. Initial configuration is the main function. The input and output ports are configured, global interrupts are enabled, and the LCD screen is initialized. Main loop, the status of the alarm and sensors is handled, and the LCD screen is updated accordingly within an infinitive loop. Alarm logic and LCD update, a message indicating that an intrusion has been detected is displayed if a sensor triggers the alarm. Specific messages are displayed if the door on or Windows are open. This is the simulation of point 1. This is the implementation of point 1. Point 2.
Below, I will make a brief explanation about the code in Microsoft for exercise 2. First of all, the configuration of ports and peripherals is carried out. The microcontroller pins for the LCD and UART communication are defined. Ports A, B, and C are initialized as input-output as necessary. The ADC mode is configured to use the ANS pins as positive reference voltage. The UART mode is initialized at 9600 bps. LCD initialization. The LCD start up and is set to now show the cursor. Text is displayed on the LCD to indicate the locations of the rings. Main loop. You enter an infinity loop where the following operations are performed repeatedly. Sensor reading. The analog values of three channels of the ADC corresponding to the temperature sensors are read. These values are converted into temperatures using specific equations. Temperatures are converted into character strings for display on the LCD. Temperatures are displayed on the LCD at specific locations. Then data transmission via UART. Temperature values are transmitted through the UART port to another device such as a computer. These values are sent as individual bytes. Data reception via UART. Data is received from the UART port, which may be control signals from another device. This data is displayed on the LCD after converting into character strings. Time delay. Finally, a small delay is introduced before the next reading to avoid too frequent readings. Well, this is an image where you can see how is work in Proteus and in labview of exercise 2 using the previous code in Microsoft. This will be the operation of exercise 2.
Point 3. Variable declarations, put value, assigned integer to store to raw ADC value, read from the potentiometer, put 1, and signature integer to store to voltage value, converting from the ADC reading. Data and signature integer to store data received via word. Voltage filtering point variable to store the voltage calculated from the ADC rating. 16 character array to store text for display on the LCD. Configuration icon 1 0x80 configures all pins as digital except for AN0, which is set up for analog input. 3A0XFF configures all pins of port A as inputs. Initialize the LCD display and clears the display. Initialize word communication at a baud rate 9600 bps. The main loop enters an infinitive loop for continuous operation, reads the analog value from the potentiometer using ADC read, converts the ADC value to voltage 0 to 5, and converts the voltage value to an integer for display and word transmission, sends the voltage value over word, reads data received via word, converts received data to a string for display on the LCD, and the explanation of the operations. The potentiometer's voltage is read using a DC and displayed on the LCD. The voltage value in the transmit via word to the ordered PIC microcontroller. Additionally, the PIC microcontroller receives data from the other PIC microcontroller via word and displays it on the LCD. This code establishes a communication link between two PIC microcontrollers, allowing them to exchange data potentiometer voltage in this case via word while displaying their respective potentiometer values on an LCD screen. This is the simulation of point 3. This is the implementation of point 3. Thank you for watching.